So in this section, we will focus our attention on substitution rule. Okay, so we have two objectives. One is you will be able to evaluate integrals using substitution rule, and you will be able to solve applied problems involving integration by substitution. Okay, so remember in the previous lesson we evaluate the integral of different kind of functions, and pretty much all of them are pretty simple functions, by the way. But there are some other functions and some other situations where the formula that we have learned so far is not enough to answer. Okay, so in that case, there are many ways to evaluate the integral. There are many methods, by the way. Okay, some of the methods, if the simple antiderivative formula is not enough to evaluate the integral, then we use different methods. For example, substitution rule, integration by parts, numerical integration, and so on. Integration by partial fraction, trigonometric substitution. Okay, there are so many methods, but today we will focus our attention on one method, which is called substitution rule. And later in our next class, we will talk about integration by parts, integration by partial fraction, numerical integration, and those other different methods, different technique to evaluate the integral. But today, let's talk about substitution rule. And in this method, we will be following this step. I want you to read that by yourself, but I think just by reading the methods, reading the steps doesn't make sense. So what I'm going to do is I will start with one example, and then I will explain what you need to do step by step. And hopefully that will make life easy to understand, okay? Let's look at example one, maybe part A. Example 1, part A. Let me just copy the question. X over 4 minus x squared dx is square root. Okay. In substitution, you need to be able to figure out what is the best, term to substitute by something else. Here, maybe let's, anyway, yeah. So one of the important thing is choice of u. Here, the bottom part seems a little bit complicated function, right? The bottom part is square root 4 minus x squared. It seems a little bit complicated. This problem cannot be solved by the antiderivative method that we have learned so far. But what we can do is we can manipulate a little bit by substituting the complicated function, which is 4 minus x squared by u. If I substitute 4 minus x squared by u, then the bottom part will be simply square root u, which means, u power half for that matter. So that's the strategy we'll be using. Okay. And then we change all x into u and dx into du. Okay. X dx change into new variable u. So du over dx is going to be, find the derivative, which will be minus 2x. Okay, minus 2x. Then your du, you can write this as minus 2x dx, or you can write du. Notice here on the top part we have x dx. So x dx, there is x dx. So we can actually substitute this value. And so I don't want that 2 there. All right, I just want this 2 there so that I can replace x dx by du over 2. So if I substitute the value, what I'm going to get is x over 4 minus x square dx is going to be x dx is du over 2, and this guy is 1 over square root u du over 2 negative. Okay, substitute all x, substitute or replace u, all x and dx by u and du. Now this is negative 1 over 2. I want to take this outside to make life easy. And so we got u power negative half du, right? That's what we get. Now this one is a pretty simple integral, right? You know how to do it. So this is going to be negative half. Let me just copy as it is. And so this will be negative half plus 1 divided using the power rule, negative half plus 1 plus c. That's it. So that means we're going to get, this looks a little ugly, so maybe you want to simplify it a little bit. Half, and then this guy will be u positive half divided by positive half on the bottom plus c. So that's going to give me negative half times 2 over 1. When you flip it, 1 over 2, if you take it there, you flip it, and then u power half plus c. This cancel out. Now, in your final answer, you don't leave it in the form of u, because u is a new variable that you introduce. So the original variable given is x. So replace the value of u back. Okay, replace the value of u back. So you're going to get integration this 4 minus x squared dx. This equals negative u means 4 minus x squared power half plus c. Right? That's it. If you want, you can write this negative 4 minus x squared plus c as well. And if you want to check your answer, whether your answer is right or wrong, you can always check yourself. So check. If you find the derivative of this, you should be getting that. So let's try. Find the derivative of negative 4 minus x squared half plus c. Let us find the derivative of this. That's going to give me negative. Okay, derivative of this will be negative half. Okay, 4 minus x squared using the chain rule. This is going to be half minus 1. Half minus 1 using the derivative, using the chain rule. So this will be negative half, and times, you need to find the derivative inside the parenthesis using the chain rule. Derivative of 4 is 0, and derivative of x squared is negative 2x, plus derivative of c is 0. So basically what you got is this negative half times negative 2x. So negative, negative, positive, 2 to cancel, you're going to get x, and 4 minus x squared negative half. So what it means is you'll get x over square root 4 minus x squared. And this is the same function that we are given here, as you can see in part A. Okay, that's how you can verify your answer yourself. Any questions so far? So part B is integral 3x squared x cubed plus 1 raised to power 10 dx. Now here, this function, this term looks a little bit complicated compared to the other one. So I want to make life easy by substituting this by u. Okay, so let us suppose that u equals x cubed plus 1. So your du will be 3x squared. Okay, and so if you just du over dx is 3x squared, so du will be 3x squared dx. So now this guy will be, this integral will be, replace that 3x squared dx. Remember 3x squared and dx together. This, they are multiplied, so you can basically write down them together, right? So 3x squared and dx together is du, and this guy is u. Okay, so this one is, this is your u, and this one plus this one together, this one and this one together is du, and this is your u. So basically we can write this as u power raised to power 10 du. That's it. Earlier it looked so complicated. Now it's simple. It looks so simple, right? And you know how to find the integration of this, which is u raised to power 10 plus 1, which is 11, divided by 11 plus c. That's it. Now don't forget to change u back into x, because u is a new variable that you introduced to make your life easy. But the original function is in terms of x. So please do not forget to change it back into the variable that was originally given, okay? So substituting value of u back, so we're gonna get, the answer is u means x cubed plus 1 raised to power 11 over 11 plus c. Done. That's the answer. So all right, we have done part B using the u substitution, and I would say this is method 1. You can do in a different way. Here what we did here is that we substitute, we suppose u to be x cubed plus 1, and we found the derivative, and we actually solve this equation for du, and we substitute the value. Instead of du, you can solve for dx and substitute the value. That's also okay. For example, what you can do is, let's say you are given 3x squared x cubed plus 1 raised to power 10 dx, and so you suppose u equals x cubed plus 1, and then your du over dx equals 3x squared. So this gives me du equals 3x squared dx, or you can solve this for dx. So if you solve it for dx, you can write du over 3x squared equals dx, and now substitute the value of dx. Now this guy will be, this integral will be, just write down 3x squared, because there is no nice form to replace this for u. I just copy as it is, and this one is u raised to power 10. Dx means du over 3x squared, okay? And this one and this one will be cancelled, so that you are left with u raised to power 10 du, and so this means u power 11 over 11 plus c, and substitute the value of u back. So your answer is going to be x cubed plus 1 raised to power 11 over 11 plus c, okay? Either solve for du, what I'm trying to say here is that either solve for du or solve for dx, okay, and substitute the value, whichever you find easy. For all these questions in substitution, either solve for du and substitute, or solve for dx and substitute. Whatever makes your life easy, go for it. Okay, now let us try one more. Let's say part H. Let's try H. H is, I'll go all the way here. H, or what is this? Which one I said? Oh, this is I. Sorry, guys. This is F, G, H, I. This should be I. So let's work on I. 2x integration 2x dx over x plus 5 square. So the first thing you need to figure out is, what do you want to substitute for u? Of course, x plus 5. Everybody agree on that? Okay. Then now du equals dx. So it's already solved for du, already solved for dx. Doesn't matter what value you want to put. So this integral becomes 2x dx. You can replace that by du over, this will be u power u square. Is it square, or what is the question, by the way? Oh, power 6. Sorry, guys, I copied the wrong question. This is power raised to power 6 here. So this is power 6. U raised to power 6. Now the question is, there are two variables. You cannot have two variables, okay? You must change everything into u. So this x must be changed into u. Otherwise, this integration cannot be evaluated. So how do we change x into u? Well, look at here. U equals x plus 5. Solve it for x, so you're going to get x equals u minus 5. So this can be written as, instead of x, I can write this as u minus 5 there. Right? So that's what I got. So this means 2u minus 10 divided by u raised to power 6 du. Right? So if I put them separately, I can write down this as 2u raised to power u power 6 minus 10 raised to power u raised to power 10 over u raised to power 6 du. So this will be, it will be 2 integration, you can write this as 2u raised to power negative 5 minus 10u raised to power negative 6 du. So that's going to give me, now you can use the power rule, which will be 2u raised to power negative 5 plus 1. Using the power rule, I think I can write directly negative 4 on the top and negative 4 on the bottom. Using the power rule, minus 10 u raised to power negative 6 plus 1, which is negative 5 over negative 5 plus c. That's it. So which gives me negative 1 over 2, okay, 1 over 2 u raised to power negative 4. So I can bring it down, making the power positive. Generally speaking, you know, when you have negative exponent, we tend to change it into positive by replacing from, you know, denominator to numerator or numerator to denominator. So that's what we do in general. So, and minus, in this case, negative and negative will be positive. So 10 divided by 5 is 2 over I want to make that power positive, so 2 over u power 5 plus c. Done. Now substitute the value back. Substituting value of u back, so you're gonna get negative 1 over 2. U means, what is u? X plus 5. So this is x plus 5 power 4 plus 2 over x plus 4 power 5 plus c. That's it. Any question? So the part z is, it's a definite integral 2 to 5, no, 2 to 10, ln x raised to power 6 over x dx. Okay. Now, first of all, one of the important questions to ask is, what do I want to suppose u to be? U equals what? That's very important. In this case, I think you have an idea by this time that u is ln x. Yes. Okay, u is ln natural logarithm x. So now you find the derivative du over dx is 1 over x. Okay. Now either solve for x du or solve for dx, doesn't matter. Okay, so this gives me du equals 1 over x dx. Or you can solve it for, dx, which is 1 over dx will be x du. So either this or this, doesn't matter. Okay. Now one thing very important. This 2 and 10 is the limit for x. Now you replace that x by u, then you must change the order of, the limit as well. Okay. So changing limit. Remember, we suppose we have u equals ln x. So when x equals 0, sorry, not 0, 2, when x equals 2, your u becomes ln 2. Does that make sense? Okay, and when x equals 10, your u becomes ln 10. That's it. So we change the limit. Now, this limit will change into, 2 will change into ln 2, and 10 will change into ln 10. Now, this will be ln x means u raised to power 6 over x, and dx means x du. Okay, dx means x du. So this x and this x cancel out. So basically what you got is, you'll get ln 2 ln 10 u raised to power 6 du. Look at this, so simple, right? Earlier it looked so complicated, but now it changes into a very simple function, and that's the power of substitution rule. Now this becomes u raised to power 7 over 7 plus c. But remember, we don't write c here because it's a definite integral, no c. Okay, u raised to power 7 to 7 and ln 2 to ln 10. And our variable is u. Now just substitute. You already know the fundamental theorem of calculus, part 2. According to that theorem, we will be writing this ln 10 raised to power 7 over 7 minus ln 2 raised to power 7 over 7, right? That's it. If you want, you can write down this as 1 over 7 ln 10 power 7 minus ln 2 power 7. You can write that way too. But if you want to change it into a numerical value, then can you use your calculator and let me know what is the numerical value here? Okay, in this example, the marginal price is given. Given P prime of P represent price, not the profit, which is given 300 divided by 3x plus 25 square. This is given. And it is also given that find the price supply equation if the distributor of the shampoo is willing to supply 75 bottles. Okay, P of 75 is $1.60. So this is given. Okay, now you need to find price P of X. That's what you need to find. So we already know from our previous class that price P of X is actually antiderivative of the derivative, right? We know that. So antiderivative of derivative, which is 300 over 3x plus 25 square dx. Now I want you to evaluate this integral. Okay, let us evaluate the integral and then I just copy and paste there. So to evaluate this integral, 300 divided by 3x plus 25 square dx. So your u will be 3x plus 25. So du over dx is 3. This gives me du over 3 equals dx. Okay, now let us substitute the value. So 300 dx is du over 3. And then this guy is over u squared. So that's going to give me 100 u negative 2 du. Right? 3 times this is 100. And so du over u squared, which is you can write u power negative 2 du. And that's going to give me 100 u negative 2 plus 1 is u1 over negative 1 over negative 1 plus c. Okay. All we got here is that we just solve it and we found that the antiderivative is going to be, so the antiderivative of this function is, oh, we need to substitute the value, by the way. Okay, substituting the value, substituting a value of c back. So this will be negative 100 over u means 3x plus 25 plus c. Okay, so let me just copy. What we got here is that this is what we got. P of x is negative 100 over 3x plus 25 plus c. That's all we got. Now the question is we need to find the value of c. Okay, because in order to find the exact price function, we need to find the value of c. So we found the price function, which is negative 100 divided by 3x plus 25 plus c. Now we need to find the value of c. In order to find the value of c, the initial value condition must be given. And the good news is, yes, it is given, as you can see here, okay? Using that value, so what is given here is that given P of 75 equals 1.60. This is given. So what you can do is price is 1.60 equals negative 100 divided by 3. X means 75. 75 or 76? 75. Okay. 75 plus 25 plus C, and then solve it for C and let me know what is the value. Okay, so when you solve it, you got 2. I trust you guys, this is the correct answer. Okay, if this one is wrong, that is your problem. So make sure that this calculation is right. So substituting the value of C, let's say this is my equation 1. Substituting a value of C in equation 1, we get our price function P of x is 100 divided by 3x plus 25 plus 2. That's it. So this is the main concept for this section, substitution rule, and we have seen substitution rule for indefinite integral. We have seen substitution rule for definite integral, and we have used the substitution rule to solve real world problems. So these are the 3 goals that I stated at the beginning of the class, and this is what we have done already. Now I want you to try the remaining questions, at least 2 questions maybe. Okay, and I'll provide the detailed solution of every single question here in my lecture note later in Canvas. But right now, if you have time, you may want to work on maybe this part F. Okay, part F quickly, and E also, maybe E and F. Let's try that.